At 03:14 hours local time, the first Flamingo cruise missile struck the component warehouse at the Alabuga Special Economic Zone in Alabuga, Tatarstan, 1,300 kilometers from the Ukrainian border. The 1,150-kilogram warhead punched through the corrugated steel roof and detonated inside the central storage bay, where between 200 and 350 Iranian-manufactured turbofan engines were stacked in shipping crates alongside pallets of composite fuselage panels, guidance electronics, and warhead components waiting to be fed into the assembly line next door. The blast pressure exceeded anything the warehouse structure could absorb. The walls blew outward, the roof lifted, cracked along its central beam, and collapsed inward onto the burning cargo. A fireball climbed 200 feet above the factory campus, illuminating the surrounding buildings in flickering orange light and throwing long shadows across the drone assembly halls, test facilities, and storage hangars stretching along the eastern edge of the Special Economic Zone. But this was not just another warehouse fire in the Russian interior. The Alabuga Special Economic Zone was where Russia built the weapons that terrorized Ukrainian cities every single night. This was the factory that assembled Shahed pattern kamikaze drones using Iranian transferred technology, North Korean labor, and Chinese-sourced electronic components. 300 drones per month rolled off this production line. 300 composite-skinned, turbofan-powered weapons that flew at treetop altitude across the Ukrainian border every night, diving into apartment buildings, hospitals, power stations, and schools, while families huddled in basements listening to the air raid sirens that had become the soundtrack of their lives. Last night alone, 115 of these drones had struck Kiev alongside 24 ballistic missiles, killing 17 people and wounding 44 others in one of the deadliest nights of the entire summer. Ukraine had just struck the source, and the man who found it was not a soldier or a spy. He was a 29-year-old data miner sitting in a windowless office in Dnipro, surrounded by energy drink cans and 4 monitors, reading Russian job postings that nobody else thought mattered. His name was Taras Belinsky. He was a cyber intelligence specialist assigned to a joint SBU-GER digital exploitation cell. His job was to extract intelligence from the digital waste that Russian companies and personnel carelessly scattered across the open internet. Social media posts, job recruitment listings, industrial procurement databases, shipping manifests left exposed on publicly accessible servers. Every piece of data that a careless employee, a boastful worker, or a poorly secured database left visible to anyone patient enough to look. Most of what he found was routine: supply chain data for civilian manufacturing, logistics schedules for commercial freight, the kind of information that filled hard drives and led nowhere. But Taras did not look for the obvious. He looked for the anomalies hiding inside the ordinary. 3 weeks before the strike, Taras was running a routine keyword crawl through Russian industrial recruitment platforms when he found a cluster of job postings from a company registered at the Alabuga Special Economic Zone. The postings sought composite materials technicians, GPS inertial navigation calibrators, small turbofan engine assembly specialists, and quality control inspectors with military electronics experience. Every posting required a security clearance and offered a salary 3 times the regional average. The company name traced through 2 layers of shell registration to a subsidiary of the Russian Ministry of Industry and Trade, a civilian company that did not exist until late 2023, registered at an address inside a special economic zone that was supposed to be building consumer electronics. Taras began pulling the thread. He cross-referenced the postings with social media profiles of workers listing Alabuga as their employer. He found vKontakte and Instagram posts showing dormitory rooms, commute routes, cafeteria meals, and occasionally the exterior of buildings, delivery truck license plates, and crates stamped with shipping codes that should never have been photographed. One worker posted a selfie in front of a building with a partially visible sign reading, "Assembly Complex 3." Another photographed a parking lot filled with military-registered transport trucks. A third posted a video of his evening walk that captured, in the background, a forklift moving a crate stenciled with Cyrillic text matching the format used for Iranian defense exports. Taras mapped the entire campus using this open-source data, combined with commercial satellite imagery. He identified 6 key buildings. The main airframe assembly hall where composite fuselage panels were joined and wired. The engine installation facility, where Iranian pattern turbofan engines were mounted and tested. The guidance module integration building, where navigation units and target programming systems were installed. The warhead loading and final inspection center, a massive component warehouse receiving shipments from Iran, China, and domestic Russian suppliers. And a finished drone storage hangar where completed Shaheds were staged before truck delivery to launch sites across western Russia. Then he found the critical vulnerability that changed everything. By tracking shipping manifests from a Russian logistics database that was improperly secured on a public-facing server, terrorists discovered that Alabuga received a bulk shipment of Iranian-manufactured turbofan engines every 14 days. The engines arrived by rail from a port transfer facility on the Caspian Sea coast, were unloaded at a rail siding on the eastern edge of the campus, and stored in the component warehouse before being installed into drone airframes on the assembly line. Without these engines, the drones could not fly. Russia had attempted to reverse engineer the Iranian engine design, but domestic production had not reached the quality or volume needed to replace the Iranian supply chain. If the component warehouse was destroyed during the 48-hour window after an engine shipment arrived, the blast would destroy hundreds of engines in their crates, and the next shipment would not arrive for another 12 days. 12 days of zero engine supply would halt the entire production line. He presented his analysis to his cell commander, Lieutenant Colonel Pavlo Marchenko. Marchenko reviewed the data carefully and then shook his head. Belinsky, Alabuga is 1,300 kilometers from our nearest launch point. That is deeper into Russia than we have ever struck with any weapon system. The flight path crosses 5 oblasts of Russian territory. Air defense coverage, electronic warfare, and the sheer distance make this operationally impossible with current assets. Write up the campus map and send it to the Strategic Targeting Archive. Maybe someday we will have the range to reach it. Terrace did not send it to the archive. Over the next 16 days, he built a complete strike dossier that transformed someday into next Tuesday. He mapped every air defense system between Ukraine's border and Alabuga using satellite imagery, intercepted radar emissions data, and Russian military enthusiast forums where servicemen occasionally posted photographs that revealed equipment positions. He found a critical weakness in the deep interior coverage. Russia's air defense network was concentrated along the western border regions and around Moscow. East of Moscow, the coverage thinned dramatically. The systems protecting Alabuga itself were limited to one S-300 PM battery and 2 Pantsir S-1 systems positioned on the campus perimeter. The corridor between Nizhny Novgorod and Kazan, the last 300 kilometers of the approach, had minimal radar coverage because Russia had never expected an attack from this direction at this depth. No Ukrainian weapon had ever reached this far into the Russian interior. He calculated the flight path. The Flamingo cruise missile had a range of 3,000 kilometers. Alabuga was 1,300 kilometers away. That left 1,700 kilometers of margin, enough for an extended dogleg route north through Belarusian airspace, east across the sparsely defended Kostroma and Kirov oblasts, and then south into Tatarstan from the northeast. A direction Alabuga's defenses were not oriented toward, because no threat had ever come from behind them. The S-300 PM battery was positioned to cover the western and southwestern approaches. The 2 Pantsir systems faced northwest and west. An attack from the northeast would enter their blind side entirely. He timed the mission to coincide with the 48-hour window after the next Iranian engine shipment. He submitted the dossier directly to the GUR Strategic Targeting Directorate. 91 pages. His cover note read, Alabuga produces 300 drones per month. Last night, 115 of them hit Kyiv and killed 17 people. The next engine shipment arrives in 6 days. The production line can be stopped. Route attached. 3 days later, a GUR officer appeared at the Dnipro office. Pack a bag. You are coming to Kyiv. Bring everything. The attack package was designated Mlin, the Ukrainian word for mill. 32 Flamingo cruise missiles, each carrying an 1,150-kilogram warhead with a range of 3,000 kilometers, flying at low altitude using terrain-following radar, AI-assisted navigation, and optical landmark recognition. No Sitchin decoys, no behemoth support drones. The extreme distance made a mixed formation impractical. This mission relied entirely on the Flamingo's stealth, range, and autonomous navigation to reach a target deeper inside Russia than any Ukrainian weapon had ever struck. 32 missiles, 32 chances to silence the factory that built 300 drones every month. At 2000 hours local time, 32 Flamingos launched from concealed sites across western Ukraine at staggered intervals over a 90-minute window. They climbed to cruise altitude, banked northwest into Belarusian airspace, and began the long dogleg route east. Their terrain-following systems activated as they crossed into Belarus, dropping to 50 meters and hugging the ground beneath the cloud cover. The night was overcast with heavy clouds and rain falling across the entire route. For 3 hours, nothing happened. The Flamingos flew east through the forests and farmland of Kostroma and Kirov oblasts at 50 meters altitude. These were areas with no significant radar surveillance, no military installations, no air defense batteries, just endless birch forests, small villages, and occasional highway crossings beneath them in the darkness. At 50 meters altitude against the ground clutter of rural Russia, the cruise missiles were nearly invisible to any surveillance system scanning from the west. At 23:41 hours, the formation approached the Nizhny Novgorod surveillance zone. The Nebo-M multiband radar southeast of the city detected a cluster of low-flying returns moving east at 550 kilometers per hour. The operator flagged the contact immediately, but hesitated on classification. The targets were heading east, not west. Russian air defense doctrine assumes threats originate from the west. Eastbound low-altitude contacts were more consistent with Russian military aviation transiting between bases than with an incoming Ukrainian attack. The operator requested classification assistance from the regional command center. That request took 4 minutes to process. At 550 kilometers per hour, 4 minutes meant the formation covered another 36 kilometers toward the target before anyone understood what was happening. At 23:45 hours, the contact was reclassified as hostile. The engagement order was transmitted to the S-400 Triumph battery at Kazan, the primary air defense system covering the Tatarstan industrial zone. But the battery's radar was oriented west and southwest, covering the traditional approach corridors. Rotating to cover the northeastern approach took 31 seconds. The battery commander ordered the first salvo. 4 missiles launched, accelerated to Mach 4, and raced northeast toward the incoming formation. The first missile locked onto a Flamingo and destroyed it at 19 kilometers. The second found its target and detonated cleanly. The third tracked a Flamingo that dove into a river valley and lost it among water reflections and terrain clutter, self-destructing above the riverbank. The fourth chased a target banking behind a ridge and overshot. 4 missiles. 2 kills. 30 continued east. A second salvo launched immediately, but the Flamingos had scattered across a wide front, each following its own pre-programmed route toward the target. 1 Flamingo destroyed. 2 missiles lost targets in ground clutter. 1 missed entirely. A third salvo. 2 more kills. 1 missile damaged a Flamingo's tail section without bringing it down. 1 missed when the target crossed behind a forested hill. 12 S-400 missiles total. 5 Flamingo kills. 27 remained, and were now less than 200 kilometers from Alabuga. At 00:17 hours, the Pol 21 GPS jamming belt activated across the Alabuga defensive zone. Satellite positioning on every Flamingo became unreliable. Coordinates drifted wildly. Flight paths began curving toward false waypoints. But the Flamingo was designed for exactly this environment. Its terrain-following radar continued painting the ground ahead, maintaining altitude at 50 meters without satellite input. Its optical navigation system locked onto the Kama River below, following its distinctive curves, bridge crossings, and riverside structures as landmarks that no jamming signal could erase. The AI compared terrain features to a preloaded map and corrected course continuously, without any external signal. The Flamingos stabilized and continued south, as if the jamming curtain did not exist. At 00:38 hours, the S-300 PM battery on the Alabuga perimeter detected the incoming formation at a range of 41 kilometers. 6 missiles launched in 2 salvos of 3. The first salvo caught the lead group emerging from behind a tree line north of the campus. 2 Flamingos destroyed. The third missile lost its target against industrial park clutter on the outskirts of Yelabuga. The second salvo arrived 10 seconds later. 1 clean kill, 1 near miss, 1 missile chasing a false return from the damaged Flamingo's tail. A third salvo destroyed 2 more. 8 S-300 PM kills total across 3 salvos. 22 Flamingos remained. Range to target, less than 8 kilometers. At 00:44 hours, both Pantsir S-1 systems on the campus perimeter opened fire. The northern Pantsir launched 2 missiles, one kill at 4 kilometers. One missed behind a perimeter wall. The western Pantsir fired 2, one kill. One missed when the target crossed behind the warehouse at the last second. Both systems switched to cannon fire. 5,000 rounds per minute per system created overlapping curtains of tracer fire above the campus. 3 Flamingos were shredded immediately by direct hits. But missiles were arriving from multiple angles, and the crews could not cover every approach simultaneously. While the northern Pantsir focused northeast, 2 Flamingos approached from the east below its coverage arc. A Flamingo struck the ground 40 meters from the northern Pantsir. The blast cracked the radar housing and jammed the turret mechanism. The system was out of the fight. The western Pantsir destroyed 2 more with cannon and 1 with its final missile, but was now the only close-range defense covering the entire campus against targets arriving from every direction. 13 Flamingos crossed the campus perimeter. Factory security guards opened fire with AK-12 rifles from positions along the fence. A Rosgvardia rapid reaction team deployed cord machine guns at the main gate and began firing at the dark shapes screaming overhead. At 550 kilometers per hour, each Flamingo crossed the campus in under 4 seconds. Ground fire hit nothing. At 0048 hours, 5 Flamingos dove into the component warehouse. The first punched through the roof and detonated inside the central bay. Engine crates shattered and ignited by the fireball, spreading through stored materials. The second hit the eastern loading dock, destroying a railcar still parked from the engine delivery 2 days earlier. The third struck the western storage section, where composite panels and guidance electronics were stacked. The fourth drove a second pressure wave through the already collapsing structure. The fifth cratered the access road and destroyed 2 transport trucks. Within 30 seconds, the entire Iranian engine shipment was burning inside a collapsing steel shell. At 0050 hours, 4 Flamingos dove into the airframe assembly hall and engine installation facility. The first detonated above the assembly floor, throwing jigs, wiring stations, and partially completed airframes across the building. The second collapsed the northern wall onto the production line, burying equipment under concrete and steel. The third destroyed the engine test stand and mounting equipment in the adjacent facility. The fourth hit the connecting corridor between buildings, severing the production flow and creating a wall of fire between the airframe and engine halves of the manufacturing process. At 0052 hours, the final 4 Flamingos dove into the guidance building and power infrastructure. The first detonated inside the navigation programming hall, destroying calibration rigs and terrain-matching database servers. The second hit the testing section, where completed guidance modules were run through simulated flight profiles. The third struck the campus primary power substation, severing electrical supply to the entire complex. The fourth targeted the finished drone storage hangar, but was hit by Pantsir cannon fire 300 meters short. It slammed into the ground beside the hangar, blasting a hole through the exterior wall, but leaving the main structure standing. An estimated 40 to 60 completed drones inside survived intact. By 0104 hours, Alabuga was burning across 4 major buildings. The component warehouse was fully engulfed, the Iranian engine shipment destroyed inside. The assembly hall was gutted and partially collapsed. The engine facility was wrecked. The guidance building was destroyed. The power substation was a blackened skeleton. Fire crews from Alabuga arrived within 40 minutes but could not contain the warehouse fire, which burned for 31 hours as composite materials, chemical solvents, and turbofan engine fuel fed the flames. The damage assessment completed 6 days later showed devastating but not total destruction. The component warehouse was gone, with every Iranian engine inside. The next shipment would not arrive for 12 days, and when it did, there would be no warehouse to receive it. The assembly hall was gutted. The engine facility was wrecked. The guidance building was obliterated, its calibration equipment and servers reduced to melted components. But the finished drone storage hangar survived, with 40 to 60 completed drones. The warhead center survived with shrapnel damage. Russia retained the engineering knowledge, the Iranian partnership, and the workforce. Within 4 to 6 months, limited production could resume at backup facilities. Estimated impact: Shahed output dropped from 300 per month to near 0 overnight. Without engines, without an assembly line, without guidance calibration, the factory could not build a single drone. For every month Alabuga stayed down, 300 fewer drones would fly toward Ukrainian cities. 300 fewer families diving into basements at 3 in the morning. 300 fewer air raid sirens screaming across Kyiv, Odessa, Kharkiv, and Dnipro in the dark hours before dawn. The strike did not end Russia's drone program forever. It silenced the factory that built 300 of them every month, and for every Ukrainian family that heard silence instead of an air raid siren in the months that followed, the man who found the job postings had already earned something no classified archive could contain. In the windowless office in Dnipro, Taras Belinsky's monitors still displayed the Russian industrial recruitment pages, where the first thread appeared 3 weeks earlier. The job postings had been taken down. The vKontakte profiles had been scrubbed. The shell company registration had been dissolved. His name did not appear in any communique or briefing. But the 91-page dossier that turned a careless Instagram selfie and an unsecured shipping database into the deepest strike in the history of the war sat in a classified archive in Kyiv, stamped with a word that a 29-year-old data miner from Dnipro never thought he would see attached to his work: approved.